Hello friends, welcome to our online channel. Myself Chetan Jadhav. In previous lecture we have seen that what is a computer-aided process planning, its type, and its advantages and functions. So today's lecture we will see computer integrated manufacturing. Okay. What is mean by this SIM? So it is the integration of CAD/CAM and business function of integrates all functions. Computer integrated management manufacturing is a new kind of management philosophy theory. It is used in organizing, managing, and running the enterprise's production. It takes advantages of computer software and hardware, managing technology, manufacturing technology, information technology, and automatic technology. It integrates the three relative factors of person, technology, running management in the whole process of the enterprise's production, as well as information flow and material flow, and runs then optimally to make service excellent, bring product to market timely, and realize products with high quality, low cost, so that enterprises will win the market competition. So computer integrated manufacturing is nothing but just organizing, managing, and running the enterprises production, and they are going to product to market, bring the new product to market on time and with high quality, low cost, and they will win the market competition. So computer integrated manufacturing has the capability to large automated flexible manufacturing by coordinating work cell, robots, automatic storage, and material handling capacity of system. Okay, so it is the one of the automate system where we are going to automate flexible manufacturing with robots, automatic storage, material handling system, like this. So SIM uses the computer to design, plan the production, control the production, and perform the business functions. So this is the information of the SIM, or we can call as a definition of the computer integrated manufacturing. So next point, now you can see the computer integrated manufacturing functions. There are four pillars. One is the first CAD, then second in terms of the manufacturing planning CAM, in terms of manufacturing control CAM, and last one is in terms of the business function. So in that first CAD, here we are going to give some geometrical information to that machines. Engineering analysis we are doing in this section. First of all, we have to give some input to that part in terms of their geometrical information, all dimensions. Then we are going to create some one model, and for that we are going to create some analysis, then review, evaluation, then final drafting, and then we are going towards the manufacturing. In terms of we are going to create some planning for the cost estimation, computer-aided process planning for NC part programming, then some computerized work is there, then some material requirement planning is there, capacity planning, then manufacturing control process planning is there. So monitoring is there, shop floor control is there, inspection is there, and afterwards a business function that has a order quantity according to accounting, payroll. So this is the overall the functions of that computer integrated manufacturing. It is nothing but we are going to collect or integrate the all functions, different departments in a single department, and we are going to doing the further process for the production. Okay, so this is the computer integrated manufacturing function. Next important type or point, that is the elements of SIM. So first, marketing, part and product design, tool and fixture design, process planning, production planning, purchasing, manufacturing, automation, storage and retrieval, information management, and finance. So these are the main elements of the SIM. So we will see one by one. First, marketing. In that, marketing is the first element of the SIM system. The purpose of this department is to identify the need of the product in the market and later on selling product in same market. So this is the very much important first element of the thing. So we have to first take the review or survey in market. We have to identify some needs of that product in the market. Why we are going to produce that product? So we have to first we have to identify the need of the product. Later on we are selling that product in the same market. So this is the first element. Second, part and product design. There are 4 steps in part and product design. First, preliminary design. Second, refinement. Third, analysis. And last, implementation. In this element, first of all, we have to draw the first design. Afterwards, we will go for some refinement, some processes. Then we are going to analysis, and last one, implementation. Final design, implementation. So this the design department is responsible for this task, and this department uses various softwares for the same processes. Okay, so this is also important element. Third, tool and fixture design. In that, tooling engineers using CAD tool develop the system or fixtures that produces the parts. So before going to manufacturing, tooling engineers, by using CAD software tool packages, they are developing some tool and fixture for producing the part. So this is also important element. Next, process planning. So in that, the process planners design a plan that outlines the routes, operations of the machining and tool required by using computer aided process planning. It also attempts to minimize the cost, manufacturing time, machine idle time, while maximizing the productivity and quality. So in this process planning, we have to design as such like routes, operation, machining tools by using CAPP. 2, we can minimize the cost, we can minimize the manufacturing time, machine idle time, and while we will get some more or maximum productivity with good quality. So that is also important element. Next, production planning. There are 3 concepts using here, including material requirement planning and machine loading and scheduling. So this is also most important in production planning. So we have to some planning. We have to do some planning regarding material, how to raw material we will store in that inventory control work in process, how we manage all this regarding that material requirement planning, how we will provide such raw material to that particular machine for particular part production. So that is also most important part. So machine loading and scheduling, so that is important part in the production planning. Next, purchasing. After preparing all the plans, whatever that production process plan, tool and fixture, part design, marketing, after that we have to the purchase department take care of this purchasing and follow up these orders. The department is responsible to receive the right material, inspect the material and send it to the appropriate place. So only this purchasing department has to done that they receive the right material, then inspection of that material and send to the appropriate place for the further process. That is only task in this purchasing department. Next, that is the manufacturing. This is the actual activity of the producing the product. This is the part of the actual manufacturing process after this all above elements, including turning, drilling, milling for material removal operation. So whatever that first 6 element is there, after that all the plannings, we are currently in activity like a such that actual manufacturing. In that we have to do such different operations like drilling, milling, turning, facing, whatever that for material removal operation. So such operations will be happening in this manufacturing department. Next, automation. This is the integrated part of the manufacturing process. It consists of computer integrated manufacturing or computer controlled machines such as CNC, that is computer numerical control, DNC, direct numerical control, FMS, flexible manufacturing system, and robots, etc. So this is where we are studying this chapter, automation. We are going to integrate a different department for manufacturing the good quality of products. Within less time we will get more productivity. So for that we are using various computer control machines like CNC, DNC, FMS, robots, AGV, conveyors, etc. So this is also important elements of the sim. Next, storage and retrieval. So in that this task involves the storage and retrieval of the raw materials, work in process, finished goods, and equipments. Actually in this part elements we are just store the raw materials after the that good finished parts, equipments, any work in process, machines, equipments. That is why we are storage and retrieval of the this different requirements as per the that manufacturing processes. Next is information management. It involves the master production scheduling, database management, communication management, information system. Actually in this information management we have to do some the planning related to the master production scheduling. We have to collect all the information regarding that particular part production in a database. We have to update that database regarding that part, and we have to do some communication with that particular part manufacturing and information system. We have to store all the information system. We have to update up to date regarding that part manufacturing in this information management. That's why this is important elements in sim. And last one, very important, that is finance. It involves the proper investment, working capital, cash flow control, accounting, and allocation of the funds. So this is also most important part of this sim. So we have some finance before going to start any manufacturing. We have to some first planning, proper planning for investment, working capital, okay, so accounting, allocation of the funds. So these are the some important elements of the computer integrated manufacturing. Okay, so we will see next point, that is advantages of computer integrated manufacturing. That is the first, product quality improvement. So by using this various department into one a single department, that is a computer integrated manufacturing, we are going to integrate all the departments, so we will get more accuracy, more quality products. So we will improve the products quality, shorter time in launching new product in the market, because of we are going to integrate all the departments. That's why we'll reduce time for launching any product in the market. Flow time minimize, due to that automation we are going to minimize flow time in manufacturing. Inventory level reduced, so we have to supply the right material to right place at right time. That's why we are reduce inventory level. Also we will get more competitiveness, improved scheduling performance. We are going to master schedule planning is there, so that's why we will improve our performance. Shorter vendor lead time, improved customer service as per requirement of the customer. We are going to supplying the demand. Increase in flexibility and responsiveness, total cost minimize, long-term profitable increases, customer lead time minimize, manufacturing productivity increases. By using all this sim technology, we are going to reduce lead time, we are going to increases productivity, work in process inventory also decreases. So this is the some advantages of the computer integrated manufacturing. So while using this system, we will get this type of the advantages in manufacturing process. So this is the about computer integrated manufacturing. So we'll see before going to MRP, we'll see automated material storage system and it is important. It consists of a variety of the computer controlled systems like automated guided vehicles, conveyors, robots for automatically placing and storing the material at a defined surface storage location. So in the industry, in the sim system, we are using various automatic material storage system. In that, you can just take example of the AGVs, conveyors, robots for placing and storing the material purpose. So we are using various automation systems. But why we are using this automated material storage system? It will give much time spending in searching, which can be avoided. So systematic arrangement by using this AMSS, saving a space, danger can be avoided in case of the hazardous material. So rather than we are moving manually that parts in line, manufacturing line, we can use this automated material storage system. They will avoid this hazardous cases. So that advantages we will get from this automated material storage system. So that's why purpose we are using the AMSS systems in automation industries. So next part, that is a materials requirement planning. So MRP, it is nothing but to get right material to right place at the right time to minimize the inventory cost. So main objective of the MRP is just simply we get the right material to the right place at the right time for minimizing the inventory cost. That will be lead to the more productivity. In order to do this MRP utilization, the master production schedule we have to do. The major objective of MRP is an organization are the following. First, we have to reduce the inventory. Second, realistic commitment for the delivery of the finished product. So first is we want to reduce the inventory. It will be save our cost money. Second, we have to real to that commitment for the delivery of the customer. And in order to apply this MRP, it is necessary to have the full inputs from the following parts. So that is the first, the master production schedule, which describes when each product is scheduled to be manufactured. Bill of material, which lists exactly the parts or material required to make each product. Production cycle time, material needs each stage of the production cycle time. And last, supplier lead time. So before going to use MRP, we have to do some master production schedule for that particular manufacturing. Then we have to make bill of material, each and everything details regarding that parts, products in terms of the materials, that cost and number of the pieces. Then production cycle time and material, we have to reduce that each stages of the production time. Supplier lead time, so we have to reduce that supplier lead time. So this is the some overview about the MRP. So you can see here just MRP information chart. So like that, first part is master schedule planning, bill of material, production cycle time, and last supplier lead time we have discussed. So next you can see there are some just overview about the MRP objectives. What is the main objective of the MRP? Now you can see the first dimension, that is inventory. So we want to reduce the inventory in MRP. In that master production schedule planning, we have to do like the planning which will give more profitability and we will get more profit. So in that inventory, we have to do order the right part, order the right quantity, and order at right the time. So it will be reduce inventory and that will leads to the more profitability. Next, priorities. Order with the right due date and keep the due date valid. So that is the priority in the MRP objectives. Capacity, plan for a complete load, plan for accurate load, plan for adequate time to view future load. So that three dimensions you have to keep in mind at the time of the planning of the MRP. Inventory, priorities, and capacity. So Likewise, there is objective specifies, so you have to take care at the time of the MRP planning. Then next is, this is the stages in MRP master requirement planning. So first, that is the inventory status, MRP, bill of material, and master schedule planning. These three pillars of the MRP. So from these three inputs, we are going to planning MRP, and from that MRP, we are going to give order release, order rescheduling, and planned order. So these are the some stages in MRP where we are giving input as inventory status, bill of material, master production schedule to MRP, and then MRP will give the following things related to that specific part. So MRP is a time-phased prior planning technique that calculates the material required and scheduling supply to meet demand. So from these stages we'll get some advantages from this MRP. That is the first, it will be time saving. Next, shortage of the inventory never occur in the system because all this master production schedule is already done. Overlapping or order can be avoided because our that planning for order release, order rescheduling, and planned order, from this we can avoid our overlapping of the order. So this is the advantages of the master requirement planning. So this is about MRP. Next, that is ERP, that is nothing but enterprises resources planning. So it is nothing but a business management software that a company can be uses to collect the store and manage the data from many business activity, including first product planning cost, manufacturing service delivery, inventory management, payment, feedback from the customer. In that is the product planning cost. So in that business software, they are going to just, before going to manufacture, they are going to planning, or they are going to predict that product cost. That is a beneficial thing. So before product produce, we have to just predict that the product cost, because afterwards we are going to, before starting any planning for the product, we have to do for the survey in customer market survey. From that we have to identify the some need from the market to win the market competitive. So that is the first is important. Next, manufacturing and service delivery. So we have to take care of in time of the manufacturing, and after the service delivery we have to take sales and services. After that we have to take some reviews and opinions from the customer and market survey. Next, inventory management. We have to do some MRP planning. In that we have to take care of the inventory planning also, management. That will save our money cost. Payment, feedback from the customer. That is the important point. Feedback from the customer. Depends upon the feedback from the customer, we are going to improve our product design. Okay, so this is the overall business software, managed software. So we can just manage the collect the data, then store the data, then manage the data from the different activities regarding that part. So next part, so again the simply new definition of the ERP. Enterprises Resource Planning System is a fully integrated business management system conveys functional area of the enterprises like logistics, production, finance, accounting, and human resources. It organizes and integrates operation process, information flows to make optimum use of resources such as main material, money, and machines. So we are going to just utilize manpower, material, money, and machines in this ERP. So following some enterprises resources planning promises one database, one application, one user interface for the entire enterprises. We once disparate systems rule the manufacturing, distribution, finance, and sales. So for that ERP we are going to create one database, one application, one user interface. So this is about the all business management software. So we will see some benefits from this ERP system. So reduce paper document. So by providing one-line formats for the quickly entering and retrieving information. So in that software we are going to create one format, so it will be easy for the entering the all data related to that part manufacturing. So it will reduce the paper documents and it will be so fast. Improve the timeliness of the information by permitting posting daily instead of monthly. So instead of the monthly update the data, it will be easy for the daily updating data, or it will be beneficial for the improvement for that particular information. Greater accuracy of information with the detail contain a better presentation, satisfactory for the auditors. So in that, just reading of this information particular part, so that will be greater, so it will be better presentation for the just identify or reading of that particular part details. Improved cost control, faster response and follow-up on the customer. We can easily take the follow-up and response from the customer in the market by using this software. More efficient cash collection, say material reduction in delay in payments by customer. Better monitoring and quicker resolution of the queries. By using this software we can easily monitoring and quickly resolution of any corrections. Enables quick response to change in business operations and market conditions. Helps to achieve competitive advantages by improving its business process. Improves supply demand linkage with remote locations and branches in different countries. By using this software we can easily maintain this link supply to demand with the different remote locations where not easily we can capture the area and branches in different countries. We can easily manage our linkage in between the supply to demand by using this software. Improve international cooperations by supporting variety of the tax structure, invoicing scheme, multiple currencies and languages. Improve the information access and management throughout the enterprises. We can easily access the information throughout our enterprises. So these are the some benefits of this ERP. Next point, that is a rapid prototyping. So rapid prototyping is nothing but a term refers to class of technology that can automatically construct a physical model from the computer aided design data. So in this rapid prototyping, some steps involved for the creating any physical model. So first of all, that a CAD model is constructed and then converted into the STL format, that is standard triangular language, to input the sliced data. Next, that is a software processes that STL file by creating sliced layer of the model. The resolution of the built model depends upon the layer thickness. Whatever that quality of that model is totally depend on the thickness of that layer. Last step, that is a rapid prototyping device create the first layer of the physical model and it repeats the layer until the model is completed. So these are the three main steps in rapid prototyping, and the main advantages of this system is almost any shape can be produced and time and money saving from the 50 to 90% compared to the conventional system. So in this system you can see there is one example additive process. We are going to create a physical model by using this RP technique, RP rapid prototyping, by using layer by layer thickness. So typical layer thickness could be near about 0.05 to 0.15 mm. So this is one of the example of the rapid prototyping. You can see here in that figure A, which is a CAD data from this computer. So that CAD data we are going to transfer STL file, and that STL file is creating the sliced layer by layer model. And figure last C, that is the RP, that is the rapid prototyping device create the first layer after that physical model until the model is completed. That RP is going to create the layer by layer on that model. So by using these RP techniques we are going to create the model. So we'll see once again what is the steps in this RP. So first of all, we have to create the 3D model in computer. After that, we have to convert that model into STL format. After that STL format, we are going to slicing the STL file into the thin layers, and after that we are going to constructing the model one layer atop another. One by one layer we are going to create the physical model, and last cleaning and finishing the model. Then we will get a 3D model, a physical model within one manufacturing process. There is no tooling process required, there is nothing here. So there are some RP technique is there, that stereolithography is there, second selective laser sintering is there, fused deposition modeling is there, 3D printing is there, laser engineering net shaping is there. So these are some rapid prototyping technique is there. So by using these techniques we can create the any physical model. So we'll see next point, that is advantages of the rapid prototyping. First, that is almost any shape or geometric features can be produced. So by using this RP techniques, we can easily create any type of the shape and geometric feature. Reduction in time and cost. So by using this technique, we can reduce the time and cost in terms of the 50 to 90%. Okay. So errors and flaws can be detected at any early stage. You can detect any error, any fault in early stage. Rapid prototyping can be used in different industries and fields of life. We can use medicine, art, architecture, in marketing also. So discussion with the customer can start at early stage also. Assemblies can be made directly in one step only. So we are using the rapid prototyping techniques. In that we are going to using only one step, one process for making any physical model. There are no any different steps or different tooling required for that particular model, physical model. So that material wastage is also reduced. No tooling procedure also required. The designers and machinery can be in a separate places. So that designers should be for different places, that machinery should be placed in a different place for the manufacturing for that part design. So these are the some advantages of the rapid prototyping. Next, disadvantages of the rapid prototyping. The price of machinery and material is very high, because this is the advanced machining, so cost will be high. The surface is usually rougher than the machining surfaces. So in this rapid prototyping we will get some surface is rough rather than this machining surfaces. Some material is brittle in this rapid prototyping. The strength of rapid prototyping parts are weaker in Z direction than in other. So whatever that we have created, that physical model, that will be weaker in Z direction. So this is about the rapid prototyping, how we are going to using this rapid prototyping techniques, what are the functions, what is the advantages and what are the disadvantages of this RP techniques. So the chapter number 4 automation is over. So thank you so much.